Find the derivative of y equals f of g of h of x. Then evaluate y prime of 0, where we have all that information. Y here is a double composition of functions, f of g of h of x. We don't know what h or g or f are, but we have h inside of g, which itself is inside of f. That's the double composition. And therefore, the derivative will involve the double chain rule. The derivative y prime, or dy dx, will start with the outermost function, take its derivative, we will call that f prime, leave the inside of it alone, so g of h of x, then we multiply by the derivative of the inside of that, which would be the g, we will call that g prime, leave its inside alone, h of x, and then we multiply by the derivative of its inside to complete the double chain rule, h prime of x. So there's our derivative y prime, or dy dx. The next thing to do is to evaluate y prime of 0. Y prime of 0 means to plug a 0 in for each of the x's. So we will have f prime of g of h of 0 times g prime of h of 0 times h prime of 0. So y prime of 0 equals f prime of g of h of 0. h of 0 is right here. It's a 5. So we'll have g of 5. We have g prime, again of h of 0, and that's again a 5. And then we have h prime of 0. That's down here. Obviously, there's a lot of extraneous information, so be really careful, but that's a negative 3. So we have this is equal to f prime of, now we need to look up g of 5. g of 5 is right there. And g of 5 apparently is a negative 4, so we would have f prime of negative 4. And then g prime of 5, that's down here. G prime of 5 is a 7. And then we have this times a negative 3. So y prime of 0 will equal to, the next thing we need to look up is f prime of negative 4. That is right here. F prime of negative 4 apparently is a 6. So we have a 6, and then a 7, and a negative 3. 6 times 7 is a 42. 42 times negative 3, which will give us negative 126.